All right, we're almost done. Almost done with the summer work. Um, and we're going to deal with some exponents and scientific notation. Um, so, reading the directions, simplify the expression, write your answer as a power. We're going to simplify, just meaning we're going to multiply the exponents are 3 and 4 to the third power to the fourth power. And the base of this exponent is 3/7. And the base of this exponent is 3/7. It's both of them because there are parentheses there. So very important. When we have like bases and we're multiplying, we're going to add their exponents. So that is 3/7 to the 3 plus 4. And this only works when we have like bases because they are the same base. And that is 3/7 times 3/7 times 3/7 times 3/7 times 3/7 times 3/7 times 3/7. And so logically, we have 7 3/7 multiplying themselves. And that's as far as you need to go. Um, Here we have a power of a power. So we again have an exponent, and the base of this exponent is 8 squared. So when we have a power of a power, we are going to multiply their exponents. So that ends up being 8 to the 18th. And the reason being is we have 8 squared times itself 9 times. And there's going to be 9 of those. And so that's 2 plus 2 plus 2 plus 2, 9 times, or 2 times 9. So you get 8 to the 18th. Simplify the expression. This time there are 2 terms inside. Not 2 terms, but there are 2 items in there. And this power of a power gets actually distributed. So that is 2 to the 1 times 3, because this is 2 to the first, times x to the 1 times 3. It's a power of a power still, but we have to also recognize the exponents in there. So this becomes 2 to the third, x to the third, and 2 to the third is 8, so I think they want you to simplify it to 8x to the third, would be my guess. Division, when we have like bases, here are our exponents again. We have to the 6th power, to the 4th power, and our bases are x. When you have like bases and you're dividing them, what do you do with their exponents? You subtract them. So that gives us x to the second. And think about it, x to the 6th. You got 6 x's, 3, 4, 5, 6. 1, 2, 3, 4. This produces a 1. X over x equals 1. This produces a 1. This produces a 1. This produces a 1. So 1 times 1 times 1 times 1 is 1. And then you're left with x squared. So that's why that works that way. And going back to this one, just so you understand, we have, as I said, times 3/7 times 3/7 times 3/7 times 3/7 times 3/7 times 3/7. And much like the other one, these don't cancel, but you end up with 1, 2, 3, 4, 5, 6, 7 multiplying itself, which is the power. So that is 3 and 4. So you get 7. Division again also. This time you have 2 to the 6th minus 8. That minus is the division part that's represented. And you get 2 to the negative 2. And that's acceptable. You can leave it. Sometimes the directions say no negative exponents. It doesn't say anything of that nature. But if we look at this, This actually equals 1 over 2 to the second also. Either answer is correct. And we understand and we see how you get the negative exponent, but if you do 2 to the 6th, 3, 4, 5, 6, and then you have 8 in the denominator. 1, 2, 3, 4, 5, 6, 7, 8. And again, this makes 1, 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 this makes 1. This time you have 2, but they're in the denominator. Notice this is down there. That's why these are equal. These are equivalent. This just represents in the denominator. Negative exponents. Which number approximates this? So for every decimal place is equal to base 10. So my decimal starts here, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was 9 places. So that would be equal to 2.258, etc., times 10 to the 9th. So we have 2 times 10 to the 9th. Which number approximates? Now we're moving in the different direction. We're making a smaller number bigger. Negative, remember, is small because it's in the denominator. So we're moving it until it makes between 1 and 10. 1, 2, 3, 4, 5 gets us to 8.3. So that's times 10 to the negative 5 because we moved it 5 places. So we're going to get that answer. Write the number in scientific notation. That's going to be 3.79 times 10 to the 1, 2, 3, 4, 5, 6. 3.79. Remember, this is a big number, and so that's where the bigness went. We took a big number, made it small. So where did the bigness go? Here is the big. That's where the size is. Write the number in standard form. So if we're going to convert it to standard form, we're going to take that decimal and we're going to move it 6 places. 1, 2, 3, 4, 5, 6. We make the decimal and we add the zeros. So that's going to be 3,790,000 would be my answer. Just making sure, looking at the work. Yep. I mean, those are 8 and 9 are identical to each other. It's just going in the other direction. Find the difference. Write your answer in scientific notation. Okay, this is interesting. We cannot subtract these two when they don't have the same base. But if we make this the same base, if we bring this to, if we make this 10 to the negative 3, that would be okay. And so we're adding a 0. So that would actually be 96. These are equivalent. And then you can subtract them times 10 to the negative 3. And as we notice, we would subtract those, and you would have 96 minus 1.1, and you got to borrow. That gives me 9. This gives me 4, so 94.9. Now that's negative 94.9 times 10 to the negative 3, because these will just continue to be place values. And now it says write it in scientific notation, so I still got to move this, and that's going to give me negative 9.49 times 10 to the, now I made it smaller. So where did the bigness go? I needed to put the bigness here. This is small, so I need to make it a little bit bigger. And so we got negative 9.49 times 10 to the negative 2. Where is that one? Oh. No. I moved in the wrong way. I made it bigger, and then I made this bigger. That actually should be smaller. Sorry. Made a big mistake on that one. Think about it. If I'm making this small to bigger, well, I can't make this bigger also. This actually has to go smaller. But the idea is there. The idea was correct. So that's actually 0.96 because I have to balance it. If I make big, that means I got to make this small. So things increase on one side and decrease in the other in order to keep it balanced. And we'll still subtract 1.1 from 0.96. I got to borrow again. That's 4. Got to borrow. That's 1. That's going to be 0.14. I think I did that correct. Yep. So we're going to get 0.14 times 10 to the negative 3. And now I actually have to move it smaller. So we got 1.4 times 10 to the, what do I want to make? I made that number bigger, so this has to be smaller, so minus 4. So that should be our answer, 1.4 times 10 to the negative 4. Sorry about that. Find the product. When we multiply, that's only when we add and subtract that we do that. Adding and subtracting, we have to have the same, you have to have the same base number. You have to have the same exponent or base 10 number. When we multiply, we don't. You can just multiply because this is really 4 times 10 to the second times 4 times 10 to the second. Completely different from this. This is multiplication, subtraction. So this is all. So we're going to multiply like with like. That gives me 16. And then like with like. And that's going to give me times 10 to the 2 plus 2, or 16 times 10 to the 4th. And then this number needs to be between 1 and 10. So we're going to move that decimal point one place. So we get 1.6 times 10 to the 5th. I made something big smaller. Where'd that big go? So as this makes smaller, this has to get bigger to balance it. So number 12 deals with quotient, division. So division we can continue to utilize. We'll take the number 6.6 divided by 8.8. And then when we divide these like bases, it's just going to be times 10 to the 3 minus negative 5, because the division is the subtraction. We have like bases. So we're dividing these and then dividing these. And when we divide it, we're just writing it like that. So 6.6 over 8.8 is just like 66 over 88. And 66, 11 goes into that. 11 goes into 66 6 times, 6/8, 6/8. And that's times 10 to the 8th, because 3 minus negative 5. This becomes 3/4 times 10 to the 8th. 3, half. And then 3/4 as a decimal is 0.75 times 10 to the 8th. And now we have to make this in scientific notation. So we'll move it over one place, which now becomes 7.5. And we made something small bigger. So where'd the smallness? So we have to subtract 1 from that, which makes this smaller. So we get 7.5 times 10 to the 7th. And that's a fun one. And that's where your knowledge of this really makes you efficient. I'm attacking this problem. We're not hemming and hawing. We understand the rules and the laws of this, and we are very efficient. Write the expression using exponents. Since we have the same number multiplying itself 4 times, we can write that 2.1 to the fourth. No parentheses needed, even though it's got a decimal, but that would just be 2.1 to the fourth power. Evaluate the expression. We have, this is an interesting, so let's look at this. Negative 8 squared is completely different from the quantity of negative 8 squared. This equals the opposite of 8 times 8, which equals negative 64. This equals negative 8 times negative 8, which equals positive 64. The exponent, this is a very important concept. The exponent is 2, and the base of that exponent is 8. The exponent here is 2, and the base of this exponent is negative 8 because of parentheses. There's no parentheses here, so this is saying the opposite of 8 squared. The opposite of 8 squared. This says the quantity negative 8 squared, so we have negative 8 times negative 8. So we have exponents, addition, and division. We're going to do the exponent first. So this, as we see, gives us negative 64 plus 18 divided by 3. Now we're going to do the division. 18 divided by 3 is 6. And then we have negative 64 plus 6, which gives us negative 58. Simplify the expression. So we can simplify this. We're going to, this is a vinculum. Sorry, I don't want that. This is a vinculum, so we're going to do everything in the numerator first and then do the division. So we'll simplify that. That is going to be 9 to the 6 plus 0 plus 4 over 9 to the 7th. 6 plus 0 plus 4 is 9 to the 10th divided by 9 to the 7th. Since we're dividing like bases, this is 9 to the 10 minus 7, or 9 to the 3rd. Find the sum. Write your answer in scientific notation. Since we have like bases, what we can do is we can add these two, and we could get 6.1, 3.4, 2.7 times 10 to the second. Now, we're not adding these exponents because we're adding these. So that's just going to be 6.1 times 10 to the second. That's a nice, easy one. What number was that? Yeah, 6.1 times 10 to the second. Real nice and easy. So completely different from multiplying and dividing. How many nanometers are in a decimeter? Ooh, nanometer. Okay, so this is kind of like King Hector died drinking chocolate milk. The only difference is, stop writing it in pen. There we go. I want to make this a little bit smaller so we can see all of the unit conversions. So this is small, this is smaller. So we have, let's put them in. So decimeter, centimeter, millimeter, micrometer, and nanometer. And this makes it smaller. So this is going small to smaller. I guess I could have done it the other way. How many nanometers are in a decimeter? So we have 1, 2, 3, 4. So I would say that that is not 4,000. Hello. I'm going to say, so 1 decimeter. So 1, and then I would move that decimal point 4 times. So decimal point is here, and we moved it 1, 2, 3, 4 times. So we'll move it 1, 2, 3, 4 times. Add the zeros in there. 1, 2, 3, 4 zeros. So there are 10,000 nanometers in 1 decimeter. That is not the case. Oh, hello, because it's not 1. Hello, this is 9. It was not, sorry. 1, 2, 3. Sorry. So this is 1, 2, 3. Micro is actually 6 units away, sorry. So hold on, let's do this. So let's move this over a little bit. So that's to the -1. So we have this other unit, 4, 5, 6 would be micro, 7, 8, 9 would be nano. So if we're going to go from a decimeter to nanometer, we're actually going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So here's my 1, and we will move it 1, 2, 3, 4, 5, 6, 7, 8 times. Add the zeros this time. And we get 3, we get 100 million nanometers. 100 million is the correct answer. 100 million nanometers, and that is correct. Yeah. Nanos is equal to 1 decimeter. A tear, not a tear, a tear in an aircraft hull has a length of 1.4 times 10 to the -4 inches. The tear becomes 1,000 times longer. What is the new length of the tear? So we're going to increase by 3 units, and that means we'll have to decrease this by 3 units. So I'm going to say that is, well, that's 1 times 10 to the -4 times 10 to the 4. 10 to the 4, 10 to the 3, 10 to the 3, 3 zeros, hello. So since we have like bases, that's 1.4 times 10 to the -4 plus 3, because we're multiplying like bases. That's 1.4 times 10 to the -1. That's how big the tear is. I like that. What is the new length of the tear? Write your answer in scientific notation. Yeah, that's good. Evaluate the expression. So we can turn these. We can turn this into 3.2 times 10 to the -1, because we moved it one place, but these have different ones. So if I want everything to be the same, let's all move them to 2s, or we can move them to 1s. Let's move them to, we can move them to, what's the best way to do this? Well, let's make this, we'll move it 2 places. We'll move it 2 places, and that'll be -1. So 1, 2. So that is 0.07 times 10 to the -1 plus that. So now we can add the numbers together, and that's going to be 3.27 times 10 to the -1. So we just added those two together. And then we can subtract this. Let's make this a -1. Yeah, that's good, right? That was good. I think I'm right there. Yep, that's good. So if I make this, that's -6 times 10 to the -2. So I'll make this -6, 0.6 times 10 to the -1. I like that. I think I like that. And then we subtract those two. 3.27 minus 0.60. 7, borrow, 6. 2.67. 2.67 times 10 to the -1. Write your answer in scientific notation. Yeah, that might be right. 2.67 times 10 to the -1. I love it. So hopefully you're understanding what I'm doing there. I'm just getting the same. When we add and subtract, we want to have the same exponents. So we can just add those base numbers. The area of a rectangle rectangular region is 7.26 times 10 to the 3 square feet. The length of the rectangular region is that. How much does it cost to surround the region with a border? That costs, okay, the area of the region is square feet. So if we take the square root of that, we would get the length. The length is this. Got it. So we're going to divide that to get the width. Got it. So we're going to get 7.26 times 10 to the third is the area, divided by the length, 1.21 times 10 to the second. So we'll divide these two. 7.26 divided by 1.21. 1.21 gives us a nice clean 6. So that equals 6. And then we will divide this, which is subtraction, times 10 to the 3 minus 2, 6 times 10 to the first. Okay, so now we have our length and our width, and we need to find the perimeter. Well, so the length, this is the width. The width is 60 feet, and the length is, what was it, 2.6 times 10, 7.2, no, that's the area. The length was 1.21, 1.21 times 10 to the second, which equals 121 feet. Okay, so the perimeter is going to be 2L plus 2W. Perimeter equals 2 times the length, 121, plus 2 times the width, which is 60, which is 242 plus 120. So the perimeter is going to equal 362 feet. And now it says that the border costs 80 cents per foot. So we're going to multiply cost equals 362 times 0.8, and that is going to be my final cost. 362 times 0.8, 362 times 0.8 gives us 289.60 cents will be the cost. The total cost for fencing that perimeter, that region. Nice. Yes. That's good stuff. That is good work in there.